This video is looking at some examples of how we can balance symbol equations. So in this first example we can see I've got two hydrogens because there is a little 2 after the hydrogen that says it's two hydrogens chemically bonded together. I've got two oxygens, again bonded in the same way. These are both covalent molecules, and then I've got another covalent molecule which has got one oxygen and two hydrogens bonded onto it. So at the moment the hydrogens look like they're balanced, but I've got two oxygens on this side and I've got one oxygen on this side. So I'm only allowed to put big numbers in front of the molecules to say that I'm increasing the number of molecules. I cannot change the chemical structure of a molecule. So I'm going to put a 2 just here, and that has said now that I've got two of that whole molecule. I've got two molecules of H2O. So I've now got on this side of the arrow 2 times 2 hydrogens, so I've got 4 hydrogens, and I've got 2 oxygens. So my 2 oxygens are now balanced because I've got 2 oxygen here, 2 oxygen here, but I've got 4 hydrogens in total on this side and only 2 hydrogens on this side. So I'm going to put a 2 in front of that, and I've now got 4 hydrogens here and 4 hydrogens here. That is now balanced. Now looking at question 2, we quite often have this situation where we've got 2 atoms of an element on one side of the equation, and then we've got 3 atoms of that element on the other side of the equation. And the simplest thing we can do when that happens is make both sides up to 6 atoms. Okay, so to do that, I'm going to put a 3 here because 3 times 2 equals 6 bromine. And then I've got 3 here, so I'm going to put a 2. 2 times 3, we've got the 6 bromines there. So the Br is now balanced on either side with 6 on either side, okay? Remembering I can only put numbers in front of the molecules. I've now got 2 aluminiums here, so I need to put a 2 here to balance it out, and that is now completely balanced. Okay, let's have a look at question 3. So we've got 1 calcium atom here. We've got a covalent molecule of oxygen, O2 here, and we've got an ionic molecule of calcium oxide over here. So we've got, the problem here is not the calciums at the moment, it's the oxygen. We've got 2 oxygen here, 1 oxygen here. So let's go for putting a 2 in front of there, and that balances out our oxygens, and now we've got 2 calcium here, so we need a 2 here to balance that out, and that is now balanced. Okay, we've got the same situation here that we had in problem 2, where we've got 3 oxygen on this side and 2 oxygen on this side. Okay, now I could go straight in for the carbon or the iron, but because I've got carbon on its own, I've got iron on its own, that indicates to me that I'll leave those till the end. Okay, whereas the oxygen, it's always in a compound, so I'm going to look at the oxygen first, and I see that I've got 3 oxygen here, I've got 2 oxygen here, so I'm going to do that same trick I did to make them up to 6. So here I'm going to go for 2, and here I'm going to go for 3. So that gives me 6 oxygens and also 6 oxygens. Now I can look at my carbon or my iron, doesn't matter which one I do next. I've got 3 carbons here, and so I'm going to put a 3 there, and I've got 2 times 2 Fe's. Okay, so that's 4 of the iron atoms. So I'm going to go for a 4 there, and that's now balanced. Okay, this one's quite tricky because we've got brackets. So this 2 means there's 2 of everything in the brackets, so 2 oxygen and 2 hydrogen. And this 2 means there's 2 of everything in this bracket, so 2 nitrogen. And because there were 3 oxygens in the brackets, we multiply it by 2, there's actually 6 oxygens there. And so what we've got, if we look at the number of oxygens in total, we've got 3 on this side, plus those 2, so there's 5 oxygen on this side. On this side we've got 6 here, 7. So that's quite tricky to know where to go, and I think the trick here is to look at the nitrogens. Okay, we've got 1 nitrogen on this side, and we've got 2 on this side because there's 2 of everything in the bracket, so 2 nitrogen. So I'm going to go straight in for putting a 2 there, and the nitrogens are now balanced. And if I look at the hydrogens, I've got 2 hydrogen here, I've got 2 hydrogen here, so I've got 4 hydrogens on this side, and here I've got 2. So I'm going to put another 2 there to make that up to 4, and now I'm going to review. 1 magnesium, 1 magnesium, 2 nitrogen, 2 nitrogen, 2 hydrogen, plus 2 hydrogen, and there's 4 hydrogen, so 4 and 4. Now let's look at the oxygen, last one to review. 6 oxygen, 3 there, 2 molecules of the whole thing, so that's 6 oxygen, plus 2 oxygen makes 8. 2 times 3 is 6, plus 2 makes 8. So I've correctly balanced that equation. Okay, let's have a look at problem 6. So I've got 1 hydrogen here, 2 hydrogens here. I'm going to go straight in and put a 2 there. So I've now got 2 hydrogens on either side. I've got 2 chlorine here, and now I've got 2 chlorine here because I've got 2 there. I've got 1 calcium and 1 calcium, so I can say that that is balanced. Okay, let's have a look at problem 7. So I've got 2 chlorine here, I've got 1 chlorine here, I've got 1 sodium and 1 sodium, 2 of everything in the brackets there, so 2 hydrogen and 2 oxygen, but only 1 hydrogen and 1 oxygen here. So I'm going to go for a 2 here. So I've now got 2 oxygen, 2 hydrogen, 2 oxygen, 2 hydrogen. I've got 1 magnesium, 1 magnesium. I've got 2 sodium and 1 sodium, so I'm going to go for a 2 there because I've got 2 chlorine and now 2 chlorines, so that is now balanced. Okay, let's look at problem number 8. I can see I've got 2 chlorines here and 1 chlorine here. I've got 2 lithiums and 1 lithium. So instantly I think I'm going to need to do a 2 there to fix that. So the Li's and the Cl's are now fixed. 1S, 1S, 4 O's, 4 O's, 1 Ba and another Ba. We are now balanced. Okay, problem number 9. I can see I've got 2 hydrogen here and another one makes 3, and over here I've only got 2. So I think I'm probably going to be making this one up to 4 and maybe making this one up to 2, so I've got 4 hydrogens, okay? I've got 1 rubidium, and here I've got 2 rubidium. So I think I'm going to go with that plan. I'm going to go 2 there, so that's 2 of the RBs. That's 4 oxygen there and another 2 makes 6. 4 oxygen there and 1 makes 5. So that's still an issue. I've got 1 sulfur and 1 sulfur. And my hydrogens still haven't sorted. So I've got 2 there. 2 there makes 4. So if I go for a 2 here, that makes 4. And that should now sort out the oxygen. So I've got 4 oxygen there. Plus 2 makes 6. 2 oxygen plus 4 makes 6. Okay, the final problem, problem 10. I think I'm going to go straight in for sorting the carbons out first. I can see I've got 3 carbons here and I've only got 1 here. So that's going to be one of my first thoughts. I've got 8 hydrogens here and I've only got 2 here. So that will be my second thought, I think, because oxygen is on its own. So 3 carbons, let's put a 3 here, 3 carbons. 8 hydrogen, so I need a number multiplied by 2 that makes 8, which is 4. And now let's look at the oxygen. I've got 2 oxygen here. I've got 3 times 2, which is 6 oxygen here, plus 4 is 10. So a number multiplied by 2 that makes 10, 5. All balanced. Hope you found that useful. Thank you.